For the video project, me and Anthony are gonna be doing problem 8.
All right, so for problem 8, we gotta determine the reactions of the support. So that's what we're trying to solve. And we have a uniform load on a bar. So our free body will look like this. And you have A right here. And A is just a roller, so it'll only be in the Y direction. You have BY. You got BX. Because at point B it's a pin, so it's in the X and Y direction. You have the uniform load on top. Which is at 800 newtons per meter. And then you have to also include the distance. So from the edge to AY, you got 1 meter. And then from A to B, you have 3 meters. And then the height from B to right here is 3 meters. Now that we have a free body diagram, we have to find the reactions at the points. So in order to do that, we have to take the moments. But in order to take the moments, we have to find the force resultant of the uniform load. And the way we do that is we do force resultant equals the uniform load, which is 800 Newton meters. You'll times that by the distance, and the distance is 4 meters. So after doing this math, you'll get 3,200 newtons. And that's your force resultant for the uniform load. And we'll need that later when we take the moments.
So since the uniform load is going in both the X and the Y direction, you gotta use the Pythagorean theorem to find the hypotenuse. And you do that, you get 5. And we'll need the 5 for when we have to find the forces in the X and Y direction.
So now we're about to start finding the reactions. So first off, we want to take the moment about B, since B has the most unknowns. So you do a moment about B, and this would be a positive direction since the forces are pushing this way. And then this will equal 0. And then the first force you have AY, which is 3 meters away from B. And it's going in a positive direction. So it'll be AY times 3 meters. And then now you have to worry about the uniform load. So now, how we found the triangle, we have to do the X and Y direction. So we'll do, since it's going down, both of them do negative. So it'll be negative 3,200. And then since we'll do the X direction first. So it would be 3,200 times 4 over 5. And then you'll times that by the Y distance, which is 3 meters. And then after that, you'll just do the same thing, but for the Y direction. So B minus 3,200 times 3 over 5 now. And then you'll times that by 4 meters. And then once you figure that out, you'll get your AY. After taking the calculations, you'll get AY is equal to 5,120 newtons. And that would be your first reaction that you found.
So now we're finding BY, and we're gonna do that by doing plus BY minus 800 times 3 over 5. 100 instead of 3200 because we're not finding the moment for this. By, we got B 10.66 newtons. We're finding Bx, we're gonna do Fx equals 0 equals minus Bx minus 800 times 4/5. Bx equals negative 640 newtons.
Okay, that's how you would solve this kind of problem. You set up a free body diagram. You set up the reactions. You'll find a force resultant for the moment. Then you'll take the components in the Fy and the Fx direction, and that's how you'll find it.